Hello friends. So today, in the last lecture that we have completed about the some testing procedure of hardness test. So in the previous lectures we have gone with the two methods. So first of all is the Brinell hardness testing and second one is the Rockwell hardness testing. Now in the today's lecture we will just go with the same kind of the testing, that is the Vickers test. Now all those three tests are used to test the hardness of that particular material. So either it may be a steel, either it may be a cast iron, or either it may be any kind of that hardened surface. So the basic purpose of the hardness test that we are aware about, that we are just going to test the hardness of that particular surface or of that particular material. Now, in the previous lectures that we have just seen about the Brinell hardness testing and Rockwell hardness testing. So, in that Rockwell hardness testing, it is just a basically combination of Brinell as well as that Vickers hardness test. But why we just go with that Vickers hardness test, that we will just see in this particular lecture. Now in case of Brinell hardness testing, that we have seen, particularly ball indenters has been used just for the testing purpose. So for the any kind of that surface we are using the ball indenters. So that we have seen in that particular previous lectures that variety of the balls are there, and that is according to their diameters, and those balls are just used according to the loading conditions. So basically we are applying the load for minimum 10 seconds in case of that Brinell hardness testing machine, and generally 10 mm of the ball diameter we are using for the test, and there will be a variation in the loads, so that maximum up to the 3000 kg load we can be able to apply in case of Brinell hardness testing. So we are aware about that how we are going to conduct that Brinell hardness testing. So that in those particular lectures with the video also I have shown you how that Brinell hardness testing has been carried out. So basically the Vickers hardness tester works on the same principle as the Brinell hardness tester, and the way of expression hardness is also similar. So whatever may be the ASTM standard has been followed for the Brinell hardness testing, same kind of that standards has been followed for the Vickers hardness testing. So whatever may be the working principle it is there, it is similar for the Brinell as well as for the Vickers. So Vickers hardness testing, what is the basic difference in the Vickers hardness testing that we will see. Now this particular test we are using the diamond square based pyramid indenter with a 136 degree of angle between the opposite faces. So in the next slide I will just show you how that particular angles has been uh, arranged for that particular diamond shape of indenter. Now here basically instead of going with the some sort of that circular or cylindrical kind of that indenter, here the diamond indenter first of all has been used. Now we are aware about the properties of that diamond. Diamond, it is the very hard material, even though it is comes under the category of brittle, but it is the very hard material. So for the indentation purpose we are just using as a diamond just for the penetration or for the indentation purpose. So whatever may be the load variation it is there. So in the Brinell hardness test, maximum 3000 kg load we can be able to apply. But in case of Vickers, the maximum load capacity that will be vary from 5 kg to 120 kg, and we can be able to increase that particular load with the steps of 5 kg basically. So again with some sort of that machine to machine it maybe gets varied, but this is the general kind of that what we can say load carrying capacity and all those things. So it provides a continuous scale of hardness, and so it is widely accepted for the research work. Now just see, again I am telling you, this particular Vickers hardness testing is basically used for the research work. But in what we can say disadvantage of this particular method, it is a time consuming method, and that's why most of the industries are avoiding this weaker hardness testing. But for the research purpose, when we want to just go with the some sort of that closer values, the weaker hardness testing has been preferred. So it is very useful method for the testing purpose. Now weaker hardness testing machine is somewhat similar to the Brenner hardness testing machine. Nowadays, many more Brenner hardness testing machines are having the arrangement of the weaker hardness test this that can be able to use for that weaker testing purpose also, that weaker hardness number. So only the indenter has been varied and they have arranged the load carrying capacity. So in the Brenner hardness testing machine, I have shown you the both arrangements are there, that is for the Vickers as well as for the Brenner. Only the difference is that whatever may be the indenter is there we are using the ball indenter, maximum load carrying capacity is 3000. Here we are using the diamond indenter. Now this is basically the machine of Vickers hardness testing. Here we can be able to see this is the force how we can be able to apply. So through the hand wheel, the force we can be able to set. This is the microscope just to observe the indentation. Here we have to set the Vickers indenter, that is the diamond indenter what I have explained. This is the working platform on which we have to set our whatever may be the material. Then this is the power plug. This is just very advanced digital kind of that machine. So it is operated by the electricity. Then loading force and wheel. Then this is the digital screen where we can be able to see how much is the indentation, how much is the load applied. And this is all about the very advanced machine of Vickers hardness testing. So the here now here just see whatever may be the arrangement it is there, a piston and a dashpot of oil is used for controlling the rate and duration of the loading. So basically here that piston and dashpot of oil is used just for the controlation of the whatever may be the rate and the duration of the loading. The test is performed by placing the specimen on anvil and is raised. The load is then actually gradually applied to the indenter. Just I want to show you that particular video, and that's why some sort of that interruption is there. Okay, so at the latter part, we will just go with that particular video also. Here there is some sort of that technical problem with the video, and this is basically that this particular test is performed by placing the specimen on the anvil and is raised till it close to the indenter point. So here whatever may be the digital and all those aspects are there, that test has been we can be able to carry it out. Now the load is then gradually applied to the indenter, then removed. Basically the load is applied for the 20 seconds, and after the anvil is lowered, a microscope is swung over the specimen. The diagonal of the square indentation is measured to an accuracy of 0.01 mm. So this is all about the whatever the technical things are there. So basically the load is gradually applied to the indenter for 20 seconds. Just remember those things. And the diagonal of square indentation is measured to accuracy of 0.01 mm. Now this is the formula for the Vickers hardness number. So that basically Vickers hardness number is measured by the two things, or we can say for the measuring of that particular number, that is hardness number, the three kind of the terms has been used. One is the Vickers hardness number, that is VHN, or it will be a VPN also, that is the Vickers pyramid number. Just note down those things, because Vickers hardness number, why it is called as a Vickers pyramid number, because in the first slide itself I have explained that is the diamond square based pyramid indenter. So that's why it will be a VPN, that is the Vickers pyramid number, or diamond pyramid number, that is DPH. Also it will be used, or diamond pyramid number, that is the DPN, that is the diamond pyramid hardness DPH, or diamond pyramid number DPN. So basically it is denoted by the HV. Now this is the formula for the VPN, basically that or VHN, that is P upon A. P is the applied load, A is the surface area of the indentation, and D is length of diagonal in mm. So here in that particular, it has been denoted by the small d here, that is written as in a capital D, but same d's are there. Then theta, it is just angle between the opposite faces, that is 136 degree. Now here it has been cleared how this particular area has been calculated. So that area, we are putting the value of area basically, and here it has been denoted by the alpha notation, but here you can be able to see how that Vickers indentation has been carried out, and this particular angle is 136 degree. Okay, so it has been now cleared. Now this is basically how those symbols and designations are there. So there is no angle when we are setting the angle. Then test load in kilogram force. So angle is 136. Whatever the test load we are applying, that is in terms of kilogram force, and we have to take the arithmetical mean of this. So the thickness, basically we are just using the at least 1.5 times the length of the diagonal of the indenter. So this is just how we have to choose the thickness, that is just standard, it has been there. So it will be a 1.5 times of the length of the diagonal. Then whatever the finishing it is required for the surface, basically it will be a precision of plus or minus 0.0005 mm, or 0.5% of the length of the diagonal. Then alignment, that is surface of the specimen should be normal to the axis of the indenter within the plus minus 1 degree of the angle. So this is all about some sort of the standards that we have to maintain while taking the test. This is the whatever with the material it is there. So in this kind of that specimens are required, and these basically those specimens are used. The whatever these two specimen is shown over here, these two specimen are used just for the calibration purpose. So basically we have to calibrate the machine. Already that hardness has been mentioned for this particular specimen, and just we have to take or conduct the test on this specimen just for the calibration purpose. So just calibration, it is again it is required, because unless and until we cannot be able to calibrate, we cannot be able to tell what will be the deviation in those readings. So basically the pincushion indentation is observed with the annealed material or whatever the metals are there, and result in overestimate of the diagonal length. if the pin cushioning indentation it is there, then on that annealed metal, then basically it has been estimated of the diagonal end, and this is due to the sinking of the metal around the flat faces of the pyramid. So this may be happen. The barrel shaped indentation is also found in the cold worked metal. So whatever maybe the indentation shapes are there, that is mentioned in this particular slide. How the indentation might be there on those particular surfaces, it has been mentioned over there. So some sort of empirical correlations for these effects are also there, whatever maybe the relationships are there. So these are the advantages how the Vickers hardness testing is having some sort of that advantages over the another methods. So basically the first advantage is the indentation always have the same shape whatever maybe the load is there. This make the measurement independent of the load, whatever maybe the measurement it is there, that is not dependent on any load. The hardness of the hardened steel or soft materials can be determined using a large or small load respectively. So whatever may be the hardened steel and soft material it is there. So basically it has been determined either by the large or small load respectively. For means it is just simply for the hardened steel we can be able to go with the larger load, and for the soft material we can be able to go with the small load. So this test is very useful for testing hardness of polished or nitride surface due to a small impression made on the test. So basically when the polished surface it is there, in case of Brenner hardness testing we are using the ball indenter, and that's why whatever may be the penetration surface it is there, it is a larger. So here because of that diamond indenter we can be able to observe those penetration surfaces, and this is the basically this kind of that indenter is there, so that's why that penetration area is very less. So when the some sort of that polished material is there, basically it is very useful for the polished material. Then basically this test is accurate and it is suitable for the metals as a thin as 0.15 mm. So if the metal is very thin, then this test is more accurate than any other method. Then these are some disadvantages of this particular method. So basically it already I have explained, that is basically it consumes more time, or it will be take a more time for every measurement, and that's why only for the research work this particular testing has been used. But most major of the industries are avoiding this testing because it is taking up more time. So that's why they are just going with the alternative methods. But when there's some sort of that irregularities are present on the measurement, then the weaker shows the more deviation than those of the Brinell test. Irregularities in the sense what? If the surface is not exactly flat, some sort of that irregularities are there on the surfaces, then whatever maybe the reading deviations are there of hardness, means for certain particular location it might be shows a different VHN, and for the another location it might be shows a different VHN, and the deviation parameters are higher than that of Brinell hardness testing. So this is one video I want to show, so you just try to understand how that weaker hardness testing has been carried out. Now basically uh, the test procedure is very similar to the Brinell. The hardness tester is semi-automatic sometimes, and in an operation in which after the specimen surface is brought close to the indenter. Okay, so this is just how the diamond indenter is making the penetration it has been shows. Now here you can be able to see this is only that tip has been manufactured, because just see diamond is very costlier material, so only that tip has been made with the diamond material, so only this particular tip. Now here we have to align this. This is the weaker testing machine. This is a surface where we want to test the hardness number. So only for the research work we have used. Now here we can be able to see on a microscope that surface, because this is the casting, that surface is very irregular. Now that load has been applied on the surface. We have to apply this particular load minimum for the 20 seconds, and that's why after 20 seconds we have to remove it. Now this is the some sort of that UV rays are there, and it has been just with the microscope, whatever may be the diagonal, it is there. They are measuring the diagonal, that is D, the test force upon the surface area of the indentation A. This is the formula. Hardness, that is HV. It is indicated with the HV. That's why it is written as an HV. So this is automatically we are getting its hardness. That is 125 HV. So it is semi-automatic kind of that things are there, and that's why we are getting the automatic readings. So I think all about whatever may be the Vickers hardness testing it is there. You are just aware about all those three testing methods which is conducted for just for the measurement of the hardness. First Brennan, second Rockwell, and third one is the Vickers. Now in the next lecture we will just go with the some sort of that another testing methods. So thank you very much for the patience listening.